Hello, smart mathematicians. Let's do question 11.1. In the diagram, chords DE, EF, and DF are drawn in the circle with center O. KFC is a tangent to the circle at F. Prove the theorem which states that DFK, angle DFK is equal to angle E. So we want to prove that this angle is equal to this angle. Okay, right. So we're going to use the previous theorems or the theorem that we have done before to prove this theorem. Right, but remember the construction. Okay, so I'm going to show you 3 different methods of proving this theorem. So just pick one that you think you are going to remember in the examination. Let's start with the first one. We have to do our construction. Let's start by constructing the diameter. Okay, if you're constructing the diameter, we're going to use the theorem that involves the radius and the tangent. Remember, the radius is perpendicular to the tangent, or the diameter is perpendicular to the tangent. And then also when you construct diameter, what else? Which other theorem am I going to use? The angle subtended by, an angle subtended by the diameter is 90 degrees, or the angle in the semicircle. Okay, just remember those 2 theorems if you're constructing what? The diameters. Okay, let's start by constructing the diameter, and then this is our diameter BF. Okay, right. So remember that the tangent and radius, or the tangent and diameter, are perpendicular to each other, and also an angle subtended by diameter is 90 degrees. So we have to create an angle subtended by diameter. So we have angle BEF there. Right, and also if you check, we have angles in the same segment there. If you check, subtended by DB there. Okay, but I'm going to explain. I'm going to show you later. And then, so what we have here, we have our angle BFK. We have our angle BFK is equal to 90 degrees. BFK is equal to 90 degrees. Why? Because radius is perpendicular to tangent. BFK is equal to 90 degrees. Radius is perpendicular to tangent. And then we have BEF. Angle BEF is also equal to 90 degrees. But what's the reason? Angle in semicircle. Angle in semicircle. And then, now, if we check our angle DEF, angle DEF, what can you say about angle DEF? It is angle 90 degrees minus angle DEB, or BED. So angle DEF is equal to 90 degrees minus angle BED. If you check, okay, please pause the video if maybe you want to check if you understand the things. Pause the video and make sure you understand. DEF is equal to 90 minus angle BED. This angle that I've highlighted in green there is 90. This 90 degrees angle minus this angle here. It will give us angle DEF. And then also if you check angle DFK is equal to what? 90 degrees minus what? This angle DFK is 90 degrees minus this angle here, which is BFD. It's BFD. Okay, we're almost there, almost done. Just 2 steps and we're done. Right, now, if you check, what can you say about angle BED and angle BFD? This angle and this angle. What can you say about them? They are equal if you check, because their angles in the same segment. They are subtended by the same chord or the same arc, dB there. So their angle is in the same segment. So this is the angle there, BED, and the angle, angle what? Angle BFD. So they are equal. They are subtended by the same segment. So if this angle is equal to this angle, then what does it mean? We can say, but angle BED is equal to angle BFD, since they are angles in same segment. So now, since these two angles are equal, so it means therefore this angle is equal to this angle. So therefore DEF, angle DAF is equal to angle DFK. You see that? So we've proved that angle DFK is equal to angle E. If you check angle DEF, that's angle E. So we can say angle E is equal to angle angle DFK. Okay, done. And then let's go to the second method. We're going to use the theorem which says angle at the center is equal to 2 times the angle at the circumference. Okay, so we have to construct the radii. So we have to construct OD and OF. You see that? And then we have to construct OD and OF like that. Okay, that's the construction. That's another method. Okay, right. But still, if you check, we have our radius OF and the tangent KC. So we're going to use the theorem, which is angle OFK. This is angle OFK. Angle OFK is equal to 90 degrees. Why? Because radius is perpendicular to tangent. Okay, right. And then what else do we have here? Angle ODF. Do you see angle ODF? Let me highlight it for you. ODF, this angle, is equal to which angle? Is equal to angle OFD. So we're saying angle ODF is equal to angle OFD. These are angles opposite equal sides, because OD and OF are radii. They are equal. So these are angles opposite equal sides. DOF is equal to 180 degrees minus 2 times, we're using the angle OFD, 2 times angle OFD. Okay, why do we say that? Angle sum in triangle. I think I need to explain this. Angle sum in triangle. If we check, we have triangle. Let me write it here. In triangle ODF. You see triangle ODF. This angle is equal to this angle. So we are saying that angle DOF plus angle ODF plus angle OFD is equal to 180 degrees. And then the reason, angle sum in triangle. You see that same reason there. And then this is equal to this. You see that? So it's like angle OFD plus angle OFD, which is just like DOF plus 2 times angle OFD is equal to 180 degrees. Then you transpose this. It becomes this. You see that? So now angle DOF is equal to 180 degrees minus 2 times OFD. Okay, so let me try to squeeze it here. 180 minus 2 times angle OFD. And then what will be this angle here? It's going to be 90 degrees minus angle OFD, because angle at the center is 2 times angle at the circumference. So we're saying, therefore, angle DEF is equal to 90 degrees minus OFD. Angle OFD, because angle at center equals 2 times angle at circumference. This angle is 90 minus OFD. Okay, but what? But angle DFK, if you check, angle DFK is also 90 minus angle OFD. 90, this whole angle 90 minus this angle OFD, but also angle DFK is equal to 90 degrees minus angle OFD. You see that? Okay, so meaning that because this is 90 minus angle OFD, this is 90 degrees minus angle OFD, so it means that this is equal to this. So you can say therefore angle DFK is equal to, no, this is DEF, not DFK, this is DEF, sorry for that, DEF. So angle DFK is equal to angle DEF. Okay, all right, this is angle DEF, and then we prove that angle DFK is equal to angle E. Okay, because angle DEF is angle E. Okay, right, let's do the last method, which is similar to the first one, almost similar to the first one, but it's a bit different. So again, we're going to construct what? We're going to construct diameter, and then if we construct diameter, remember the theorems that we're going to use. Radius and tangent are perpendicular to each other, and then also angle is subtended by diameter is 90 degrees, or angle in the semicircle. Okay, right, let's construct our diameter. So we have FB there, and then now we constructing DB instead of BE. You see that? Something like that. So we've done the construction, and then still BFK, what is it? Is equal to 90 degrees. Angle BFK is equal to 90 degrees. Radius perpendicular to tangent. We have FDB also. What can you say about angle FDB? Angle FDB is equal to 90 degrees. Okay, 90 degrees. Why? It is angle in semicircle. Angle in semicircle. We have angle B. What can you say about angle B? Angle B is equal to 90 degrees minus, because we're looking at triangle BDF. Triangle BDF is 90 degrees minus this angle. 90 degrees minus BFD. 90 degrees minus BFD, angle BFD. Okay, right, so that is angle B there. And then also if you check angle DFK, is equal to 90 degrees minus what? Minus the same angle BFD. See that? This whole angle here, and then minus this angle here, it will give us this angle. You see that? 90 degrees minus BFD. So we have 90 degrees minus BFD here, 90 degrees minus BFD here, meaning that angle B is equal to angle DFK. So therefore angle DFK is equal to angle B. Okay, right. But if you check, we have angle B subtended by the chord DF, and we have angle E subtended by the same chord. So it means angle B is equal to angle E, but angle B is equal to angle E because they are subtended by what? their angle is in the same segment. Angle is in same, not semi, same segment. Angle is in the same segment. Therefore, DFK, angle DFK is equal to angle E. Because say angle DFK is equal to angle B, then angle B is equal to angle E, so meaning the angle DFK is equal to angle E. That's the answer there. So it means these two angles are equal, angle DFK and angle E. We have proved this part here. Done. So that's what it's supposed to do there. We're going to meet when we do question 11.2.1.